A few lectures back, when we introduced supply and demand curves, I promised that at some point in the future, we get to see where those curves come from. That time is now. Today we will uncover the origins of the demand curve. And just like in any good comic book superhero origin story, in this video, we'll explain how the demand curve came to be, and in doing so, open up a new set of questions to explore in later sequels. Remember that the demand curve shows the relationship between the price of a good and the quantity demanded. We've been talking a lot about pizza and cookies, and how the prices, and more specifically the price ratio, influence how much pizza and how many cookies you want to consume. But the demand curve is just about one good. So we need to look at what happens to demand as one price changes, while the other prices stay constant. For example, suppose you have a budget of $12, and your choice of pizza and cookies at different prices is shown by the table here. So if a pizza slice costs $3 and a cookie costs $1, you'd choose to buy 2 pizza slices and 6 cookies. And if a pizza slice costs $5 and a cookie costs $3, you wouldn't buy any pizza and use all $12 to buy 4 cookies. Where did the information in this table come from? For each of these combinations of prices, we would have used the utility maximization strategy from last lecture, choosing pizza and cookies such that the marginal benefits equal the marginal costs. Note that as the price of pizza rises, at any fixed price of cookies, you want less pizza. Why is this? Because a rise in the price of pizza relative to the price of cookies is a rise in the opportunity cost of consuming pizza. You now have to give up more cookies to get a slice of pizza. And as a result, you want less pizza. Think about this in terms of the utility maximization strategy we talked about last lecture. The ratio of the price of pizza to the price of cookies is the marginal cost of pizza. So when the price of pizza goes up, the marginal cost of eating pizza goes up. We know that to be at the top of the hill, marginal cost must equal marginal benefit. Therefore, if the marginal cost of pizza is going up, then the marginal benefit of pizza must also increase. Otherwise, you won't be at the top of the hill anymore. What is the marginal benefit? It's the marginal utility of pizza relative to the marginal utility of cookies. So the marginal utility of pizza must rise compared to the marginal utility of cookies. And how do you increase the marginal utility of a good like pizza? You consume less of it. Now this might seem strange, but it's a key lesson. The principle of diminishing marginal utility states that the more of a good you consume, the lower the marginal utility. So to increase marginal utility, you need to consume less of the good. Meanwhile, to consume less pizza, you have to consume more cookies. Otherwise, you wouldn't be spending all your budget. So what does that do to the marginal utility of cookies? It lowers it. Each cookie is worth less to you as you have more of them. So looking at the marginal benefit as the ratio of marginal utilities, we see that shifting from pizza to cookies leads the numerator, the marginal utility of pizza, to rise, while the denominator, the marginal utility of cookies, falls, so that the overall ratio rises. The marginal benefit of pizza is rising to match its higher marginal cost. So let's fix the price of cookies at $1 each. And for each price of pizza on the vertical axis, we plot your demand for pizza on the horizontal axis. When pizza is $1 a slice, you buy 8 slices. But when the price rises to $3, you only buy 2. When the price of a slice goes all the way to $5, you only buy 1 slice. If we assume you can buy fractions of a slice, you can go ahead and connect the dots. And there you have it. A demand curve is born. So a demand curve is simply the graph of the quantities of the good you would purchase when you maximize your utility at each price of that good.